we need to ask the deeper question, the question that really matters. Why does a universal speed limit exist at all? What is it about the fabric of reality that enforces this cosmic boundary? The answer lies in something profound. Space and time are not separate, independent things. They are woven together into a single structure called space-time. And the speed of light is not just a speed limit for motion, it is the conversion factor between space and time. It is the fundamental exchange rate built into the geometry of the universe itself. When objects move through space, something strange happens to time. Time starts to slow down. This effect is called time dilation. It is not a trick. It is not an illusion. It is a real physical phenomenon that has been measured countless times with atomic clocks, particle accelerators, and GPS satellites. Moving clocks genuinely tick slower than stationary ones. At everyday speeds, this effect is invisible. When you drive your car at highway speeds, your time slows down compared to someone standing still. But the difference is absurdly small. We are talking about nanoseconds over your entire lifetime. Your body ages a tiny fraction slower when you are moving, but the effect is so minuscule that it makes no practical difference whatsoever. But what happens when you start moving really fast? When you approach significant fractions of light speed? The effect becomes dramatic. Time dilation stops being negligible and starts becoming extreme. At half-light speed, time runs noticeably slower. At 90% light speed, time is crawling. At 99%, time has nearly stopped from the perspective of a stationary observer. Here is where it gets fascinating. As you approach light speed, time dilation approaches infinity. Time slows down more and more and more. And at exactly light speed, something impossible happens. Time would completely stop. A clock moving at light speed would not tick at all. No time would pass. From the perspective of that reference frame, the entire journey would take 0 seconds. But there is more happening here. Space itself is also changing. As objects move faster, space shrinks along the direction of motion. This is called length contraction. The distances you measure in front of you get compressed. If you are moving at half-light speed, distances shrink noticeably. At 90% light speed, they shrink dramatically. At light speed, they would shrink to 0 length. Think about what this means. At light speed, time stops and space disappears. The entire universe along your direction of motion would collapse to a single point. There would be no duration and no distance. A reference frame cannot exist in that state. It is geometrically impossible. The mathematics breaks down completely. This is why massive objects cannot reach light speed. It is not because they lack energy. You can keep pumping energy into a particle forever. You can accelerate it closer and closer to light speed, but you can never quite get there. The energy requirements grow without bound. As you approach light speed, it takes more and more energy to produce smaller and smaller increases in velocity. Why does this happen? Because as objects gain energy, they gain mass through Einstein's mass-energy equivalence. The faster something moves, the more massive it effectively becomes, and the more massive it is, the harder it becomes to accelerate further. It is a feedback loop. Energy makes you faster, but faster makes you heavier, and heavier makes you harder to speed up. The limit is asymptotic. You can get arbitrarily close, but never quite arrive. Only massless particles can travel at exactly light speed. Photons have no rest mass. They are born moving at light speed and can never slow down. They do not experience time. They do not have a reference frame in the traditional sense. From a photon's perspective, if we could even talk about such a thing, emission and absorption happen simultaneously. The entire journey is instantaneous because time does not exist for it. But here is the key insight. Faster than light motion is not just forbidden, it is meaningless. What would it mean to go faster than light? It would mean space becomes negative. Distances would be less than zero. Time would become imaginary in the mathematical sense. The geometry of space-time itself would break. Causality would shatter. Effects could precede causes. You could arrive before you left. The speed limit is not an arbitrary rule imposed by nature. It is a consequence of the structure of space-time itself. Space and time are interlocked. They trade off against each other. Move faster through space, and you move slower through time. The speed of light is the point where this trade-off reaches its absolute limit. It is the boundary where the geometry of reality stops making sense. This is why the speed limit exists. It is enforced by the fundamental architecture of the universe. It is not like a traffic law that could be changed or broken. It is like a geometric truth. You cannot have a triangle with four sides. You cannot have a speed greater than the conversion factor between space and time. The universe is structured in such a way that the concept itself is meaningless. Faster than light motion would erase space and time entirely, not just in the reference frame of the traveler, but in the logical structure of causality itself. Events would stop having a definable order. The past and future would become scrambled. The universe would lose its coherent structure. This is not something technology can overcome. It is not an engineering challenge. It is a fundamental limit written into the geometry of existence. So when we talk about the speed of light being a limit, we are not talking about something arbitrary. We are talking about the point where reality itself breaks down, where the mathematics stops working, where the concepts of space and time cease to have meaning. The speed limit exists because space-time has a structure, and that structure has boundaries, and those boundaries are absolute. Have you ever stopped to wonder why the speed of light has such a bizarre, oddly specific value? 299,792,458 meters per second. Not 300 million, not a nice round number, but 299,792,458. What makes this number special? Why does the universe's ultimate speed limit look like someone just randomly picked digits out of a hat? Here is the truth that might surprise you. There is absolutely nothing physically special about this number. Nothing at all. The speed of light is called the universe's ultimate speed limit, and that part is real. Nothing can travel faster. No particle, no spacecraft, no information can break this barrier. But that specific number, that strange collection of digits, it is completely arbitrary. Let me explain what I mean. The number feels random because we, as humans, expect the universe to speak in clean, rounded numbers. We want everything to be nice and neat. We want tens, hundreds, thousands. We want patterns we can memorize easily. But the universe does not care about what we find convenient. The universe does not organize itself around human preferences. Think about it this way. Is there any cosmic event that happens exactly at 299,792,458 meters per second? Does anything in nature suddenly change or break or transform at precisely that value? No, absolutely not. The number itself holds no cosmic significance. It is not written into the fabric of reality. It is not carved on some universal stone tablet floating in space. So why does it look so weird? The answer lies in something we rarely think about. The answer is in our measurement system itself. The randomness comes from our units, not from physics. Miles, kilometers, meters, seconds, hours. These are all human inventions. We created them. We defined them. And here is the key point. We defined these units long before we understood anything about light. Long before we knew light even had a speed. Long before Einstein came along and showed us that light speed is the cosmic speed limit. When humans first created the meter, they were not thinking about light. They were trying to measure the Earth. The original meter was defined as 1/110 millionth of the distance from the North Pole to the equator. That is a completely Earth-based, human-centered definition. It has nothing to do with the universe at large, nothing to do with the fundamental laws of physics. The same goes for the second. When we defined the second, we were chopping up a day into smaller pieces. 24 hours in a day, 60 minutes in an hour, 60 seconds in a minute. These divisions are arbitrary. They come from ancient Babylonian mathematics and human convenience. They have zero connection to the fundamental workings of the cosmos. Now imagine this. Imagine if we had defined the meter differently. Imagine if we had made it twice as long. What would happen to the speed of light? Would physics change? Would the universe suddenly operate differently? Of course not. The speed of light would simply be a different number in our system. Maybe 149,896,229 meters per second instead. The number would change, but the actual speed, the physical reality of how fast light travels, would remain exactly the same. This is the illusion. The universe does not prefer meters. The universe does not prefer seconds. The universe does not speak in kilometers per hour or miles per second. These are languages we invented to describe nature. And when we use our invented language to measure something fundamental like light speed, we get a number that looks strange and arbitrary because our units themselves are strange and arbitrary. Change the units, and the number changes completely. Measure light speed in miles per second, and you get 186,282. Measure it in feet per nanosecond, and you get roughly 1. Measure it in Planck lengths per Planck time, and you get a totally different value. The number transforms every single time. But the speed itself, the actual physical phenomenon, never changes. This is why the speed of light looks so random. It is not because there is anything random about the physics. It is because we are looking at a fundamental constant through the lens of arbitrary human measurements. We are trying to describe something universal, using tools we built for measuring farmland and tracking sundials. The speed of light is special, profoundly special. It is the maximum speed anything can travel. It is woven into the structure of spacetime itself. It connects energy and mass through Einstein's famous equation. It determines how the universe evolves, how particles interact, how causality works. But the number 299,792,458, that is just an accident of history, an artifact of how humans decided to measure distance and time centuries ago, long before we knew what we were really measuring. One more transformation that reveals something shocking about the nature of speed itself. What if I told you that the speed limit is not really a limit? What if the problem is not physics but language? The way we typically define speed creates an artificial barrier. We measure speed as distance divided by time, meters per second, kilometers per hour. This definition works beautifully at low speeds, but it breaks down catastrophically as you approach light speed. The numbers get squeezed. They pile up against an invisible wall. You can reach 0.9 times light speed, then 0.99, then 0.999, and so on. But you can never quite reach one. The number line seems to end abruptly. This creates the illusion of a hard cutoff. It makes light speed look like a forbidden boundary, like there is some force actively preventing you from crossing over. But that is not what is actually happening. The problem is not the physics. The problem is how we are measuring. Enter rapidity. Rapidity is a different way to quantify motion. Instead of measuring speed directly, it measures something more fundamental, something that connects naturally to the geometry of space-time. And when you switch to rapidity, something extraordinary happens. The speed limit disappears. Not because physics changes, not because objects can suddenly go faster than light, but because the artificial mathematical barrier vanishes. In rapidity, there is no upper limit. You can have a rapidity of 1 or 10 or 100 or 1,000,000. The numbers extend to infinity. And here is the key insight. Infinite rapidity equals light speed, not beyond it. Let me explain what this means. In traditional speed, light speed is the maximum. Nothing can go faster. The scale ends at c, but in rapidity, light speed is at the far end of an infinite scale. You can keep increasing rapidity forever, getting closer and closer to light speed, but never exceeding it. The limit is still there physically. Massive particles still cannot reach light speed. But mathematically, the barrier has transformed from a wall into an asymptote. Why does this matter? Because it removes the illusion of forbidden numbers. In traditional speed, it looks like there should be speeds above light speed. The number line continues past c. We can imagine 1.5c or 2c. They seem like reasonable numbers, but they correspond to nothing physical. They are meaningless values that our notation accidentally allows us to write down. In rapidity, those meaningless values do not exist. There is no notation for faster than light. The system itself prevents you from writing down nonsense. Light speed sits at infinite rapidity. There is nothing beyond infinity in this framework. The language matches reality perfectly. But the benefits go deeper than just eliminating confusion. Rapidity makes relativistic physics dramatically simpler. Remember how velocity addition in special relativity is complicated? If you are on a train moving at half-light speed, and you throw a ball forward at half-light speed, the ball is not moving at light speed relative to the ground. The velocities do not add normally. There is an ugly formula with products and quotients and the speed of light squared in the denominator. In rapidity, velocity addition becomes trivial. You just add rapidities directly. If a train has rapidity of 0.5 and you throw a ball with rapidity 0.5 relative to the train, the ball has rapidity 1.0 relative to the ground. Simple addition. No weird formulas. No special cases. The math works the same way it does in everyday life. Energy and momentum equations also transform. In traditional notation, relativistic energy has that famous square root factor, the Lorentz factor. It appears everywhere. It clutters equations. It makes calculations messy. In rapidity, those square roots disappear. Energy becomes a clean hyperbolic function of rapidity. Momentum has an equally clean form. The relationships are elegant and symmetric. This is not mathematical trickery. This is revealing the true structure underneath. Space-time has a hyperbolic geometry, not Euclidean, not flat in the way we intuitively think of space, and rapidity is the natural coordinate system for that geometry. Traditional velocity is like using the wrong coordinate system. It works, but it makes everything unnecessarily complicated. Think of it this way. Imagine trying to describe positions on Earth using a flat map projection. You can do it, but near the poles, everything gets distorted. Greenland looks enormous. Antarctica stretches across the entire bottom. The map creates artifacts that do not exist in reality. If you switch to spherical coordinates, those artifacts vanish. The true shape of Earth becomes clear. Rapidity does the same thing for velocity. Traditional speed is like a distorted map projection. It works fine for low speeds, just like flat maps work fine for small regions. But near light speed, everything gets compressed and weird. Rapidity is the spherical coordinate system. It shows you the true geometry without distortion. So what does this mean for faster-than-light travel? It means the concept does not exist physically, only linguistically. In traditional velocity, we can accidentally write down speeds above c. We can talk about them, we can imagine them, but they correspond to nothing real. They are artifacts of notation. In rapidity, there is no notation for faster than light. The framework itself prevents the concept from being expressible. Light speed is at infinite rapidity. There is no beyond. The language and the physics align perfectly. This is the final revelation. The speed of light is not a random number imposed on reality. It is not even really a limit in the traditional sense. It is the natural boundary that emerges when you correctly describe motion in space-time. Traditional velocity makes it look arbitrary and restrictive. Natural units make it look fundamental but still limiting. Rapidity reveals its true nature as the infinite asymptotic endpoint of all possible motion. Faster-than-light speeds do not exist, not because nature forbids them, but because the concept itself is a linguistic artifact, a mistake born from using the wrong mathematical framework. When you describe motion correctly using the geometry of space-time, the question becomes meaningless. Like asking what is north of the North Pole. The question assumes a framework that breaks down at that point. This is the universe speaking its deepest language, not just setting c to 1, but restructuring how we measure motion itself. And when we do that, the speed limit stops looking like a barrier. It starts looking like what it really is, the infinite horizon of reality itself. So if the number 299,792,458 is just an artifact of our arbitrary measurement system, is there a better way to measure things? A way that actually reflects how the universe works instead of how humans decided to chop up rulers and clocks? The answer is yes. And when physicists discovered this better way, something remarkable happened. The speed of light stopped looking random and started looking inevitable. What if I told you that physicists have created unit systems where the speed of light equals exactly 1, not 299,792,458, not 186,282, just 1. Does that sound strange? Does it sound like cheating? It is not. It is actually the most natural way to measure the universe, and it reveals something profound about reality itself. These are called natural units. The idea is simple but powerful. Instead of basing our measurements on human-scale things like the size of Earth or the length of a day, we base them on the fundamental constants of nature. We let the universe define its own measurement system. We let physics speak its own language. In natural units, the speed of light is set to exactly 1, not approximately 1, not rounded to 1, exactly 1. This is not some mathematical trick. This is a deliberate choice to measure speeds in units where light speed is the baseline. Think of it like measuring temperatures in degrees Celsius, where water freezes at 0 and boils at 100. We are doing the same thing with speed, except our reference point is the cosmic speed limit itself. What does this do to our understanding of motion? Everything becomes clearer. Instantly, the weird, arbitrary number vanishes, and suddenly, the speed limit of the universe becomes intuitive. No speed can be greater than 1. That is the rule. That is the law. It is simple. It is elegant. It makes sense. Think about what this means for actual speeds. A speed of 0.5 in natural units means exactly what it sounds like. Half the speed of light. A speed of 0.9 means 90% of light speed. A speed of 0.99 means 99%. The numbers become meaningful immediately. You do not need to memorize strange values. You do not need to do complicated conversions. You just need to know that 1 is the maximum, and everything else is a fraction of that maximum. This is how the universe actually works. When a particle accelerates, it approaches 1. It can get closer and closer. It can reach 0.999 or 0.9999 or 0.99999, but it can never reach 1 unless it is light itself. Massive particles are always stuck below 1. Only massless particles like photons travel at exactly 1. The speed limit now feels logical instead of accidental. It feels like a ceiling, not a random cutoff. But the benefits go far beyond just making speeds easier to understand. Natural units transform the entire language of physics. Equations become cleaner. Relationships become more obvious. The underlying structure of reality emerges from beneath layers of arbitrary conversion factors. Take Einstein's famous equation: energy equals mass times the speed of light squared. In standard units, you need to write out that factor of light speed squared. You need to multiply by 299,792,458 squared, which is about 90 quadrillion. It is messy. It is cumbersome. It hides the relationship between energy and mass behind a huge number that only exists because of our unit choices. In natural units, something beautiful happens. The speed of light is 1, so light speed squared is also 1. The equation collapses into its simplest form. Energy equals mass. That is it. The relationship is direct. The relationship is obvious. Mass is energy. Energy is mass. They are the same thing measured in the same units. The conversion factor disappears because there is nothing to convert. The universe is speaking clearly now. This happens throughout physics. Momentum equations simplify. Space-time intervals become cleaner. Quantum mechanics sheds its cluttered constants. Suddenly, you can see the patterns. You can see how different phenomena connect. You can see the deep symmetries that govern reality. Does this mean physics changes when we use natural units? Absolutely not. Nothing about reality changes. A photon still travels at the same speed whether we call it 1 or 299,792,458. An electron still has the same energy. Gravity still pulls with the same force. The predictions remain identical. The experiments give the same results. What changes is our description, our language, our ability to see clearly. Think of it like translating a book from a clumsy, wordy language into a precise, elegant one. The story stays the same, but suddenly it reads better. Suddenly you notice details you missed before. Suddenly the meaning becomes clearer. Natural units reveal that the speed of light is not special because of some magic number. It is special because it represents the fundamental structure of space-time itself. It is the conversion factor between space and time. It is the speed at which causality propagates. It is the maximum rate at which information can travel from one point to another. In natural units, this becomes obvious. Time and space are measured in compatible units. They connect naturally. A light second of distance equals 1 second of time. The universe has no preferred separation between spatial dimensions and temporal ones. They are interwoven. They are part of the same geometric structure, and the speed of light, now simply equal to 1, is the thread that binds them together. This is the universe speaking its own language. This is physics without human baggage. The speed limit is not arbitrary. It is absolute. It is built into the geometry of existence itself. So if natural units make physics so much clearer and more elegant, why doesn't everyone use them? Why are we still measuring highway speeds in kilometers per hour and miles per hour? Why do speedometers still display numbers like 60 or 80 or 120 instead of impossibly tiny decimal fractions? If natural units reveal the true language of the universe, why does human society completely ignore them? The answer comes down to something simple but powerful: practicality. Human civilization is built on historical measurement systems. Every single aspect of our infrastructure, our commerce, our daily lives depends on units that were established centuries ago, and changing them is not just difficult, it is nearly impossible. Think about what would happen if we tried to switch to natural units tomorrow. Every road sign on the planet would become completely useless overnight. Speed limit signs that currently say 100 kilometers per hour would need to display unreadably small decimal numbers. Highway speeds in natural units are absolutely tiny because we are comparing them to the speed of light, and cars are incredibly slow compared to light. Imagine driving down the highway and seeing a speed limit sign that reads as a tiny decimal with 7 or 8 zeros after the decimal point. What does that even mean to a human brain? How do you judge whether you are speeding? How do you estimate your arrival time? How do you know if you are going faster than the car next to you? The numbers become completely unintuitive for everyday experience. Your brain would need to constantly translate these microscopic fractions back into something meaningful. Every speedometer would need to be replaced. Every GPS system would need reprogramming. Every navigation app would need updating. Aviation instruments, shipping logs, traffic cameras, police radar guns, everything. The cost would be unimaginable. We are talking about trillions of dollars globally to replace or recalibrate devices that currently work perfectly fine for their intended purpose. And here is the thing. We have already seen how resistant societies are to changing measurement systems. Look at the metric system. The metric system is far simpler than imperial units. It uses base 10 conversions. Everything is consistent. Meters, liters, grams. They all relate to each other logically. The math is cleaner. The conversions are easier. Yet even with these obvious advantages, many countries still refuse to fully adopt it. The United States still uses miles, pounds, and Fahrenheit for most daily activities. Why? Because switching costs enormous amounts of money. Because people are used to the old system. Because infrastructure was built around those units. Because changing road signs alone would cost billions. Even a switch from something clumsy to something objectively better faces decades of resistance and political battles. Now imagine trying to switch to natural units, where speeds become scientific notation with negative exponents, where every familiar number vanishes, where highway speeds need 8 decimal places. The resistance would be absolute and justified. But there is a deeper reason natural units do not work for everyday life. Humans never experience relativistic speeds. We never travel anywhere close to the speed of light. The fastest spacecraft humanity has ever built barely registers as a meaningful fraction in natural units. Commercial airplanes are even slower. Cars are slower still. These speeds are so minuscule compared to light that expressing them in natural units creates numbers that are essentially meaningless for practical decision-making. Traditional units were designed for human scales. A kilometre is a distance you can walk in about 10 minutes. A metre is about the length of a stride. A second is a comfortable unit of time for human perception. An hour maps naturally onto segments of our day. These units match our everyday experience. They make sense when you're cooking dinner, driving to work, or planning a vacation. They were built for a world where nothing moves faster than a jet aircraft or a speeding bullet. Natural units were built for a different world entirely. They were built for particles zipping through accelerators at nearly light speed. They were built for understanding cosmic rays that slam into our atmosphere. They were built for photon interactions, quantum field theory, and the behavior of matter at extreme energies. They were built for theoretical physics, not for traffic management or daily planning. Scientific notation does not work for everyday decisions. When you need to leave your house to arrive somewhere on time, you do not want to calculate durations using tiny decimal fractions. You want simple numbers: 15 minutes, 30 minutes, 2 hours. These are human-scale durations that map naturally onto human experience and decision-making. The same goes for distances. You want to know if something is 5 kilometers away or 50. You do not want to convert everything into fractions of light seconds and then express those fractions as decimals with multiple leading zeros. That mental translation adds unnecessary complexity to tasks that should be simple and automatic. It creates cognitive load where none should exist. This is not a failure of natural units. It is a recognition that different tools serve different purposes. A surgeon needs a scalpel, not a chainsaw. A carpenter needs a hammer, not an electron microscope. Natural units are the right tool for particle physics and cosmology. Traditional units are the right tool for human society and everyday life. Physics operates at scales where light speed matters, where particles routinely travel at significant fractions of the cosmic speed limit, where relativistic effects become important and measurable, where the structure of spacetime shapes observable phenomena. In that realm, natural units reveal truth. They strip away arbitrary conversions and show you the universe as it really is. They make equations cleaner and relationships more obvious. But daily life operates at completely different scales. Scales where gravity is weak, where speeds are negligible compared to light, where time dilation is utterly unmeasurable, where Newtonian physics gives perfectly accurate predictions for everything you will ever personally experience. In that realm, traditional units are not just acceptable, they are superior because they match human perception and needs. This is why natural units belong to theory, not traffic. They belong in research papers, not on highway signs. They belong in universities and laboratories where physicists explore the fundamental nature of reality. They do not belong in kitchens, roads, or airports, where humans need practical, intuitive measurements for everyday tasks that have nothing to do with relativistic physics. The elegance of natural units is real. The insights they provide are profound. But elegance and practicality serve different masters. By now, after exploring natural units, rapidity, and the geometry of spacetime, you can probably sense that the phrase speed of light is a little misleading. It sounds as if light itself is the reason the limit exists, as if photons are special messengers dragging the maximum speed behind them. But the truth is deeper and far more interesting. The limit would still exist even in a universe where no one had ever discovered light. Light does not create the speed limit. Light merely rides on it. Long before physicists understood photons as particles of the electromagnetic field, the underlying structure of space-time already imposed a maximum speed for any influence to travel. The limit is not about brightness or color or electromagnetic waves. It is about how space and time are stitched together. It is about the deepest rule the universe follows. Cause must come before effect. The first key idea is that the speed limit applies to everything, not just light. It applies to all forms of energy and all forms of matter. It applies to gravity itself. Changes in a gravitational field do not propagate instantaneously across the universe. They radiate outward at the same universal speed. The ripples in space-time called gravitational waves move at exactly that limit. When two black holes collide, the information about that collision reaches distant observatories no faster than this universal speed. The same is true for information more generally. Information cannot outrun the speed of light. You cannot send a signal, a message, a command, or a warning faster than this limit. No matter how clever the device or how advanced the technology, any attempt to transmit information faster than that maximum speed would collide with the fundamental structure of space-time. It is not a question of engineering, it is a question of geometry. So why is light involved at all if the story is really about causation and geometry? Light is important because it is one of the things that actually moves at this maximum speed. Photons are massless, so they are allowed to travel on the very edge of what nature permits. That makes them perfect probes of the speed limit. When we measure the speed of light, we are not really learning something about light itself. We are learning something about the maximum rate at which cause and effect can be linked. This is why the limit existed long before humans measured it. The universe has always had a maximum speed. For billions of years before anyone pointed a telescope at the sky, every particle interaction, every gravitational influence, every transfer of information obeyed that same rule. Light just happens to be the most obvious example of something that travels at that speed, so we named the limit after it. But the name hides the deeper truth. At the heart of this lies the principle of causality. Causality says that causes must precede their effects. Drop a ball, then it falls. Turn on a lamp, then the room brightens. Press a button, then the machine responds. This ordering is not just a habit of human thinking. It is a structural feature of reality. It is encoded in the way space-time is built. If you could send signals faster than the universal speed limit, that ordering would collapse. How would faster-than-light motion break causality? Special relativity tells us that different observers, moving relative to one another, slice space-time into past, present, and future in different ways. At low speeds, those differences are tiny and irrelevant, but at extremely high speeds, they become dramatic. If you had a way to send a message faster than light, then in one frame of reference it might go forward in time, but in another frame of reference it could appear to arrive before it was sent. Now imagine combining several of these faster-than-light signals between observers moving relative to each other. You could create a loop where a message is sent, received in what another observer considers the past, and then used to prevent itself from ever being sent. An event could influence its own past. The very idea of a consistent timeline would fall apart. You would get paradoxes where an action both happens and does not happen. Reality would be logically unstable. The universe does not allow this. The geometry of space-time is set up to prevent such paradoxes. The universal speed limit is how nature protects causality. It is a safeguard built directly into the structure of reality. Nothing, not matter, not energy, not information, can outrun the speed of causal influence. That is why the same limit governs light, gravity, and all other interactions. It is not that light is special and imposes its will on everything else. It is that causality is special, and light, being massless, simply reaches the very edge of what causality permits. This brings us to a more accurate way to phrase the whole idea. The speed of light is really the speed of causation. It is the fastest speed at which one event can affect another. Light just happens to be the most familiar carrier that travels at that speed, so historically it got the naming rights. But if, in some alternate universe, humans had discovered gravitational waves or some other massless field first, we might have called it the speed of gravity, or the speed of information instead. The underlying constant would be the same. When seen in this light, all the earlier pieces of the story snap together. The seemingly random number we measure in meters per second is just the human translation of a deep geometric limit. Natural units make that limit equal to 1, revealing its central role in the structure of space-time. Everyday life ignores it because our speeds are so tiny in comparison. The universal speed limit emerges from the way time slows and space contracts as motion increases. Rapidity exposes the true smooth mathematical structure behind that limit. And now, in this final step, we see that the limit is not primarily about light at all. It is about preserving a universe where cause and effect make sense. So when we say, nothing can travel faster than light, what we really mean is something even more profound. Nothing can outrun causality. Nothing can escape the logical structure that keeps the universe consistent. Light is simply the visible edge of that law, the messenger that reveals the deepest speed in nature, the speed at which reality itself updates from cause to effect. By now, after exploring natural units, rapidity, and the geometry of space-time, you can probably sense that the phrase speed of light is a little misleading. It sounds as if light itself is the reason the limit exists, as if photons are special messengers dragging the maximum speed behind them. But the truth is deeper and far more interesting. The limit would still exist even in a universe where no one had ever discovered light. Light does not create the speed limit. Light merely rides on it. Long before physicists understood photons as particles of the electromagnetic field, the underlying structure of space-time already imposed a maximum speed for any influence to travel. The limit is not about brightness or color or electromagnetic waves. It is about how space and time are stitched together. It is about the deepest rule the universe follows. Cause must come before effect. The first key idea is that the speed limit applies to everything, not just light. It applies to all forms of energy and all forms of matter. It applies to gravity itself. Changes in a gravitational field do not propagate instantaneously across the universe. They radiate outward at the same universal speed. The ripples in space-time called gravitational waves move at exactly that limit. When two black holes collide, the information about that collision reaches distant observatories no faster than this universal speed. The same is true for information more generally. Information cannot outrun the speed of light. You cannot send a signal, a message, a command, or a warning faster than this limit. No matter how clever the device or how advanced the technology, any attempt to transmit information faster than that maximum speed would collide with the fundamental structure of space-time. It is not a question of engineering, it is a question of geometry. So why is light involved at all if the story is really about causation and geometry? Light is important because it is one of the things that actually moves at this maximum speed. Photons are massless, so they are allowed to travel on the very edge of what nature permits. That makes them perfect probes of the speed limit. When we measure the speed of light, we are not really learning something about light itself. We are learning something about the maximum rate at which cause and effect can be linked. This is why the limit existed long before humans measured it. The universe has always had a maximum speed. For billions of years before anyone pointed a telescope at the sky, every particle interaction, every gravitational influence, every transfer of information obeyed that same rule. Light just happens to be the most obvious example of something that travels at that speed, so we named the limit after it. But the name hides the deeper truth. At the heart of this lies the principle of causality. Causality says that causes must precede their effects. Drop a ball, then it falls. Turn on a lamp, then the room brightens. Press a button, then the machine responds. This ordering is not just a habit of human thinking. It is a structural feature of reality. It is encoded in the way space-time is built. If you could send signals faster than the universal speed limit, that ordering would collapse. How would faster-than-light motion break causality? Special relativity tells us that different observers, moving relative to one another, slice space-time into past, present, and future in different ways. At low speeds, those differences are tiny and irrelevant, but at extremely high speeds, they become dramatic. If you had a way to send a message faster than light, then in one frame of reference it might go forward in time, but in another frame of reference it could appear to arrive before it was sent. Now, imagine combining several of these faster-than-light signals between observers moving relative to each other. You could create a loop where a message is sent, received in what another observer considers the past, and then used to prevent itself from ever being sent. An event could influence its own past. The very idea of a consistent timeline would fall apart. You would get paradoxes where an action both happens and does not happen. Reality would be logically unstable. The universe does not allow this. The geometry of space-time is set up to prevent such paradoxes. The universal speed limit is how nature protects causality. It is a safeguard built directly into the structure of reality. Nothing, not matter, not energy, not information, can outrun the speed of causal influence. That is why the same limit governs light, gravity, and all other interactions. It is not that light is special and imposes its will on everything else. It is that causality is special, and light, being massless, simply reaches the very edge of what causality permits. This brings us to a more accurate way to phrase the whole idea. The speed of light is really the speed of causation. It is the fastest speed at which one event can affect another. Light just happens to be the most familiar carrier that travels at that speed, so historically it got the naming rights. But if, in some alternate universe, humans had discovered gravitational waves or some other massless field first, we might have called it the speed of gravity, or the speed of information instead. The underlying constant would be the same. When seen in this light, all the earlier pieces of the story snap together. The seemingly random number we measure in meters per second is just the human translation of a deep geometric limit. Natural units make that limit equal to 1, revealing its central role in the structure of space-time. Everyday life ignores it, because our speeds are so tiny in comparison. The universal speed limit emerges from the way time slows and space contracts as motion increases. Rapidity exposes the true smooth mathematical structure behind that limit. And now, in this final step, we see that the limit is not primarily about light at all. It is about preserving a universe where cause and effect make sense. So when we say nothing can travel faster than light, what we really mean is something even more profound. Nothing can outrun causality. Nothing can escape the logical structure that keeps the universe consistent. Light is simply the visible edge of that law, the messenger that reveals the deepest speed in nature, the speed at which reality itself updates from cause to effect. From the very beginning, the speed of light seemed like a magic number. It looked oddly specific in our human units, as if the universe had rolled dice and landed on an arbitrary value for its maximum speed. At first glance, there was nothing emotionally satisfying about that long sequence of digits, but as we peeled back each layer, we discovered that the weirdness was never in nature. It was in our perspective. In the first part, we saw that the number for the speed of light looks random because our units are random. Meters and seconds were defined for very human reasons, tied to the size of our planet and the rhythm of our days, not to the structure of space-time. The universe never chose meters. We did. So when we stuff something as fundamental as the cosmic speed limit into these homemade containers, we should not be surprised when the resulting number feels arbitrary. The speed itself is not strange. Our way of describing it is. In the second part, we let the universe speak in its own language through natural units. The moment we set the speed of light equal to 1, everything changed. The ugly number vanished and the structure emerged. Speeds became simple fractions of the maximum allowed. Equations that used to be cluttered with conversion factors turned into clean relationships, where energy and mass, time and space sat on equal footing. Nothing in reality changed, but our description finally lined up with the geometry the universe actually uses. Then, in the third part, we faced a crucial tension. If natural units are so elegant, why does everyday life still run on kilometers per hour and miles per hour? The answer turned out to be that elegance and practicality are not the same. Human society is built on historical units that fit human scales. Our roads, recipes, and routines do not need relativistic precision. They need numbers that feel intuitive when you are late for work or planning a trip. Natural units are perfect for describing high-energy particles and curved space-time, but hopelessly impractical for traffic lights and supermarket labels. So we learned that there is no contradiction in using one language for living and another language for understanding. In the fourth part, we dug into why a universal speed limit exists at all. This was where the story truly shifted from units and convenience to the architecture of reality. Space and time are not independent backgrounds. They are interwoven into space-time. As an object moves faster through space, it moves slower through time. Length contracts, time dilates, and near light speed these effects become extreme. At light speed, time would freeze, and distances along the direction of motion would shrink to zero. A reference frame at that speed simply cannot exist. Faster than light motion would demand a geometry where space and time twist into nonsense. The speed limit is not a rule that could have been otherwise. It is a boundary built into the fabric of space-time. In the fifth part, we confronted the limitations of our own language for describing motion. Traditional speed compresses everything near light speed into a narrow band of numbers between almost light speed and exactly light speed, creating the illusion of a hard barrier that looks mathematically awkward. Rapidity gave us a new lens. In that language, the speed limit became an infinite horizon. You can keep increasing rapidity without bound, but light sits at the unreachable edge. Velocity addition became simple. Equations that once involved messy square roots became neat expressions tied to the hyperbolic geometry of space-time. We discovered that some of our confusion about the speed limit was not about physics at all. It was about trying to use a flat map to describe a curved landscape. In the sixth part, we uncovered the deepest insight. The speed of light is not really about light. Light is simply one of the messengers that travels at the maximum allowable speed. The true constant is about causation. It is the fastest rate at which information, influence, or any physical effect can propagate. If anything could move faster than that, different observers could disagree about the order of events in a way that leads to paradoxes. Signals could be arranged so that an event changes its own past. The universe would become logically inconsistent. The speed limit exists because reality demands a consistent timeline where cause comes before effect. Light rides on that limit, but it does not define it. The real constant is the speed of causation itself. When you stitch all of these parts together, a coherent picture emerges. The speed of light is not a quirky trivia fact from physics. It is the visible edge of a much deeper structure. Our human units make it look messy, but natural units reveal its role as the backbone of space-time. Everyday life ignores it because our speeds are too small to feel its effects, but high-energy physics lives by it. Time dilation and length contraction show how motion reshapes time and distance as we approach the limit. Rapidity shows that our first idea of speed was only an approximation that works well at low velocities, but hides the true geometry at high ones. And causality tells us why the limit must exist at all. So what should you take away from all of this as a young professional trying to understand the universe in a clear adult way? First, that constants in physics often look arbitrary only because of the languages we use to express them. Second, that changing the language to match the universe better can transform confusion into clarity without altering any actual predictions. Third, that the speed of light is not just about light, but about the fundamental way events relate to each other in time. The next time you see that long number printed in a textbook, you will know that behind those digits lies an entire story. A story about how space and time cooperate, about how information moves, about why paradoxes do not happen in real life, even if they are easy to imagine in science fiction. It is the story of how the universe keeps itself consistent. And perhaps the most beautiful part is this. What began as an oddly specific speed turned out to be one of the purest reflections of the universe's logic. Not a magic number, not an arbitrary limit, but the quiet rule that ensures reality unfolds in a way that makes sense. The speed of light is simply the name we gave to the ultimate pace at which the universe can update itself from cause to effect.